We're going to talk about vectors in 3 dimensions. This is probably the first time you've been exposed to 3-dimensional work. What we're doing is we're going to add another a vertical plane called the z-axis. So we'll now, instead of just the xy axis, you'll have an xy and z axis. All right, and now right now our 8th graders are being exposed to this with Blender, and they're actually learning about vectors in 3D and stuff like that. So we better in this class too. It says graph the point with an x value. It goes x, y, z with an x value of 3, y value of 5, or a z value of 4. All right, so drawing your graph's a little bit different. So far, you've just been doing things in 2D. This is 2 dimensions like this. When we do it in 3 dimensions, I'll make sure I label things here. All right, here's the z plane, here's the y plane, and here's the x plane. All right, it's basically this is laid down flat on the ground, and then the z is everything going up in the air then. All right, so this is like, think of this as a tabletop, and this is things going above the table. All right, a point above the table. So if we want to graph that, all right, so we go 3 on the x-axis. Well, we're 1, 2, 3 on the x-axis. 4 on the, or 5 on the y-axis. So 1, 2, 3, 4, 5. And then up 4 on the z. So 1, 2, 3, 4. Where all of these meet, and then way up here, that is the point 3, 5, 4. All right, it's out in space. If you can imagine, there's space between here and here. All right, it's out closer to the screen than in towards on the page. All right, so that's how we graph 3 dimensions. Representing a 3D vector in an ordered triple is the same way. We just take the terminal point minus the initial point. We learned that already for 2D. Now we just add one more. All right, so we take the x minus the x, the y minus the y, the z minus the z, starting with the terminal point, subtracting the initial point. So if we want to represent this vector as an ordered pair, all right, we take its vector, we'll say from A, form of A to B. So B is the terminal point, A is the initial point. So to represent this one, to represent AB, all right, it'll be 10 minus 3, terminal side minus initial side, -4 minus -7, and 0 minus -1. So the vector AB can be represented by this ordered pair. So it's starting at the origin, and then it goes to this point here, 7. That would be cross line change of sign. That would be a +3. Cross line change of sign. That's +1. 7, 3, 1 would be the vector for this guy in 3-dimensional space. Okay. We also talked about last time writing a coordinate or a vector as a sum of unit vectors. This can happen the same way with the 3-dimensional vector. All we do is we take the z coordinate and we add a k. So it's ijk. The x coordinate goes with the I, the y coordinate goes with the j, the z coordinate goes with the k. So here we go. Express GH, the point GH, the vector GH is a sum of unit vectors for the point G at 10, -3, 15, and the point H, 4, 1, -11. It says GH, and again, it must be a word thing. I don't have a symbol, maybe. I don't know, but it should be a line. The vector GH, line on top of that, so it means we're going from G to H being the terminal side. So first off, we got to express it as an ordered pair. So we go the terminal side minus the initial side. And then we go the terminal side 1 minus the initial side, -3. And then we go the terminal side minus the initial side. So GH, 4 minus 10 is -6. Cross line change of sign, that's 4. And that is -26. So that's it. That's GH expressed in an ordered pair again, with the initial point being the origin, the terminal point being -6, 4, -26. All right, and now we're going to write this as a sum of unit. So we just take the x value, we go -6i plus 4j plus or minus a negative 26. Okay, and that's it right there. Easy enough. Pretty easy. Hope this helps. We'll see.